welcome. Decision making or decision theory and decision making under uncertainty using probability. And now this is time of studying Bayesian or Bayesian approach to decision making. That means to use the probabilistic approach for the purpose of decision making regarding stock options, or what quantity of stock should a trader maintain when the demand levels are frequently changing. Yes, the demand levels frequently change. Say this is a case of a fruit seller. The case is a fruit seller sells strawberries. If not sold on the day of delivery, they are worthless. One box of strawberries cost rupees 200 and the seller receives rupees 500 for it. The seller cannot specify the number of customers on any one day. Yes, the seller can never determine the exact number of the probable customers on a specific day, but his analysis of the records of last 1 year shows the following results. Yes, he is maintaining records of his daily sales, and the records of daily sales for last 1 year says number of boxes sold per day are 10 for 45 days, 11 boxes 60 days, 12 boxes 120 days, 13 boxes 75 days. Total number of days, or rather working days, seem to be 300 in the last year. Okay. Find the base stock option for the seller so that he can optimize his profit. Also find the maximum amount which the seller should spend for getting the perfect information. Okay. First of all, these four are the alternatives available to the fruit seller. He has four alternatives: either to maintain stock of 10 boxes or 11 boxes or 12 boxes or 13 boxes of strawberries or whatever the fruit can be. What about the states of nature? These four things are the different four states of nature. Either the market demands 10 boxes, or the market demands 11 boxes or 12 boxes or 13 boxes tomorrow, or say today. Imagine a situation, the seller has to order the number of boxes for tomorrow on today evening. What will be his situation on today evening? Yes, he has to decide whether to order for 10 boxes, 11 boxes, 12 boxes or 13 boxes and to keep them till the end of the next day. Now he has four options. He is under confusion. If he orders for, or he keeps stock of 10 and demand of 11, 12 or 13 is there, he has to lose the customers. Or he keeps stock of 11 or 12 or 13 and the demand is less than the stock, then he has to bear the loss of the additional number of boxes. So he has to keep some balance. How can he and also can earn the optimal profit? We can use this information and say we can have a probability distribution. These are number of days. They are like favorable cases, favorable number of cases for particular outcome of the experiment. 45 days are in favor of 10 boxes, 60 days in favor of 11, 120 in favor of 12, 75 in favor of 13. So we can have probability. If this is treated as frequency, sigma f comes to 300. 45 plus 60, 105 plus 120, 225 plus 75, 300. So probability will be f divided by sigma f. So it will be 0.15, 0.2, 0.4 and 0.25. Yes. Now we have probability. So in this kind of problems, these are the alternatives available to the decision maker, as well as these are the different states of nature. Both are same. Now what to do? Since we are solving this kind of problem in our series of the lectures on decision theory very first time, I am going to use the longer method of explanation. I am not going to suggest any shortcut now. In later on in any other lecture I can suggest. Let's assume that he keeps stock of 10, then 11, then 12, then 13, and let's see what happens with the expected profit or expected payoff. So let's first, if he keeps stock of 10 boxes. Okay, now stock 10, but demand can be of 10, 11, 12 or 13. But even if the demand is 11, he can sell 10 boxes only because he has stock of 10. Similarly, if the demand is of 12 boxes, he can sell 10. He can never sell more boxes than the boxes kept in stock. So, demand can be 11 or 12 or 13, can be 10 or 11 or 12 or 13. But sales can never exceed the stock. Stock or demand, whichever is lower, will be the sales. So sales will always be 10. But what if he keeps stock of 10? He will have 10 boxes, all the 10 can be sold. So the profit will be 10 into, now his profit is actually rupees 500 minus cost 200, that is rupees 300 per box. So he will receive 3000 rupees. If the demand is 11, he can make sales of 10 only because he has stock of 10. So 3000, 3000 and 3000. In this way we can think. So now sales will be only 10 every time, profit will be 3000 because he can sell 10 boxes only. Let's find out, if we treat this as x, then P of x is here, probability of 10 boxes, probability of 11 boxes, probability of 12 boxes and probability of 13 boxes. But the reality is he can sell only 10 boxes because he has a stock of 10 boxes. He has to say no to the 11th, 12th and 13th customer. Yes, okay. What will be his profit? His profit will be 3000. This is his expected profit this is his expected profit. Now what if he keeps stock of 11 boxes? If he keeps stock of 11 boxes, demand will be he has stock of 11 boxes. If demand is 10 and stock is 11, he can sell only 10 boxes, because any seller can never make sales greater than demand or the greater than stock. So whichever is lower will be the sales. It will be 10, but he has 11 boxes and demand of 11, so he can sell 11 boxes. He has 11 boxes and demand of 12, then he can sell 11 boxes only, and similarly in case of demand of 13. But we have to take care where there are more number of boxes than demand, because these or rather such kind of cases are of perishable goods. What the 11th unsold box, he has to throw it at the evening, at the time of closing down his shop. Yes, this is the rule set. He can keep it till the end of the day only. Now what he has to do with the 11th unsold box? He has to throw it. That means the cost of 11th box, rupees 200, should be written off against the profit made from the sales of 10 boxes. So 10 into 300, the profit will be 3000. But out of which he has to write off 200, the cost of the 11th unsold box. So his profit will be 2800. Now 11 stock, 11 demand, so he can sell all the 11 boxes. 11 into 300, 3300. No loss is to be written off. Demand 12 but stock 11, so sales will be 11, 3300. 3300. $420 will be his profit. Yes, 660, 1320, 825. His expected profit will be 3225 if he keeps stock of 11 boxes. Okay, now the fourth situation possible, third state of nature available to him is, rather alternative available, if he keeps stock of 12 boxes. Yes, if he keeps stock of 12 boxes. Demand will be 10 or 11 or 12 or 13. Sales will be 10 or 12, whichever is lower, 10, 11 or 12, whichever is lower, 11, 12 or 12, 12, 12 or 13, whichever is lower, 12. But in these two cases, he has to write off the stock of unsold box. Profit, yes, his profit will be 3000 on sale of 10 boxes, but he has to write off the loss on 2 unsold boxes. 2 into 200, that means 400. So his profit will be 2600. Similarly, in this case, his profit will be 3300. 11 boxes into 300 rupees. But he has one unsold box. The loss on unsold box will be 200, so his profit will be 3100 after writing off of the loss on unsold box. 12 into 300, 3600, and no unsold box. Again 12 into 300, 3600, no unsold box. Actually, in this case, he has to say no to the last 13th customer. Yes. Okay, let's multiply it by the probability. 0.15, 0.2, 0.4 and 0.25. So the expected profit will be 2600 into 15, 390. 3100 into 20, I mean 0.2, 620. 3600 into 0.4, 1440. 3600 into 0.25, 900. And the summation will be 3350. His expected profit, if he keeps stock of 12 boxes, comes to 3350, which is higher in these three cases. Now the last alternative to him is to keep stock of 13 boxes. Okay? This is actually the process of taking a decision for a long term. For so many days, he will be keeping the stock suggested by us at the end of this kind of calculations. Okay, if he keeps stock of 13 boxes, okay, demand will be, okay, there are 4 levels, 10 or 11 or 12 or 13 boxes. Sales will be stock or demand, whichever is lower, 10 or 13, whichever is lower, 10, 11 or 13, whichever is lower, 11, 12 or 13, whichever is lower, 12, 13 or 13. So in all these three cases, he has to lose, or rather, he has to write off the loss on unsold boxes. Okay, let's calculate the profit. On selling 10 boxes, he makes a profit of 3000, but he has 3 unsold boxes, the loss on which is 600, so 2400 is net profit. If he sells 11 boxes, his profit will be 3300, but he has 2 unsold boxes, so loss 400, 2900 will be his net profit on selling 11 boxes. If he sells 12 boxes, his profit comes to 3600, but he has 1 unsold box and loss on it is 200, so his profit comes to 3400. And if he sells all the 13 boxes, there will be no loss on account of unsold box, so his profit will be 3900. 13 into 300, 3900. Yes, probability is 0.15, 0.20, 0.4 and 0.25. Let's calculate the expected profit. 2400 into 0.15, 360. 2900 into 0.2, 580. 3400 into 0.4, 1200 plus 160, 1360. And 3900 into 0.25, 750 plus 225, it comes to 975. Yes, 975. The total comes to 3275. Expected profit if he keeps stock of 13 boxes. Now, he has 4 alternatives available, and the highest profit is in case of keeping stock of 12 boxes. In case of keeping stock of 10 boxes, profit is 3000. In case of stock of 11, profit rather expected profit is 3225. In case of keeping stock of 12 boxes, the expected profit is 3350, and in case of keeping stock of 13 boxes for a long term, the expected profit comes to 3275. Actually, the thing which we never write or say, we ignore is, this is based on the last 300 days. So we believe that if this stock is maintained for these number of days, 300 days, and the situation follows this probability distribution, then the expected profit, that means average profit per day on keeping these much number of boxes in stock will be this. If he keeps stock of 10 boxes for all 300 days, then his average profit per day will be rupees 3000. That means total profit of 300 days divided by 300 will be 3000. If he keeps stock of 11 boxes for all 300 days, next 300 days, and the situation remains same, then his average profit per day will be 3225. That will be total profit of 300 days divided by 300. Yes. This thing is not written anywhere in the reference books. Yes. This is actually expected means average. All these are averages based on 300 days. So we should not forget this. This can never be proved correct for any single day or very say little number of days. Yes, this is fact. Statistics is the average, rather science based on averages. Statistics is the science based on averages. It is man-made science. It is not natural science. We just use simple arithmetic and simple algebra purposefully. So statistics is the subject which is developed by mankind for their own use. Yes, and so at this stage we can say that it is advisable for the fruit seller to keep stock of 12 boxes, which gives him the highest possible profit per day. Okay, 3350 per day. Even if he has to say write off loss of 1 or 2 boxes